Alright, this is your second day in 5.5 with more factoring. Thank you. With more factoring by sum and difference of cubes and grouping. Alright? So like I said, yes, if you're gone yesterday, you might be able to catch on a little bit. If not, come see me, get notes, look it up, stuff like that. Okay? Grouping, it's more so grouping today than it is sum of cubes, difference of cubes. But there are a little bit. What I would write down as the last paragraph, don't really worry too much about the first two, that's more talking points for me. Okay, the last 2 lines, yeah. Alright? Anytime, and I'm going to write this down real quick. Factoring flow chart.
I know that.
Still 5.5, yes. Yeah, I'm talking about the graphic organizer I have that was from that one slide where I said I was going to print it out for you guys. I have none yet. Okay, so I'm going to get you your factoring flow chart. That way you kind of know where to go with factoring, okay? So that way when you're practicing at home, because I know that's what you guys do at home, sit and do math problems. Me too, man. It's fun. That way you can practice and you know where to kind of go. All right. So for the first line, it says factoring by grouping is the only method that can be used to factor polynomials with 4 or more terms. Everything before yesterday had either 2 terms or 3 terms, or all you could do is a GCF. All right. It kind of leaves that out. That you can factor with the GCF out of any number of terms. But as far as your actual main techniques go, it was 2 or 3. All right. Today we have 4. On your homework, you could have 6. Okay. And all that does is just make your groups a little bigger. It's not that hard. Okay. For polynomials with 2 or 3 terms, it may be possible to factor according to one of the methods prior. So that's talking about your normal factoring with trinomials, where you look for an add number and a multiplied number. That's talking about your difference of squares and your perfect square trinomials. All right. The one I said to write down to make sure you get down. When factoring 2 terms in which the exponents are 6 or greater, look to factor using perfect squares before factoring perfect cubes. Okay? Not really for any mathematical reason. You can do it either way, just to make your life easier. Okay? It's just to make your life easier. To make sure, so the next example is one like that. Question number 1. X to the 6th minus y to the 6th. Looks innocent looking, right? Easy enough, okay, cool. 2 terms, a minus, no big deal. All right, now I'm going to put up a different question real quick just to see if we can compare things. All right, I'm going to say x squared minus 1. All right. That factors x plus 1, x minus 1. Okay. The reason it factors x plus 1, x minus 1 is because the signs work out that you cancel out the middle 2 when you FOIL. And then what's x times x?
X squared.
X squared. Okay? So the reason why you need to make sure you do this difference of squares first is because, number 1, it's going to be simpler math. Number 2, it's going to simplify the 2 binomials. Okay? So if x times x is x squared, what's x squared times x squared? X to the 4th. So then if I'm going to want my first FOIL to be x to the 6th, what needs to go first in my binomial? X cubed. Because your first thing when you FOIL is x cubed times x cubed, which is not x to the 9th, it's x to the 6th. Because you add those exponents when you multiply bases. Alright, see how we're taking chapter 5 exponent rules and mixing them in here now? Look at everything coming together. Alright? Just like x squared minus 1, you have 1 being plus, 1 being minus. And the same way with the x to the 6th, the y to the 6th is going to factor y cubes. Y cubed, y cubed. All right. Now, does anybody see anything that looks somewhat familiar to you? Miss Stephanie?
I'm just kind of confused how you put a y in there. So y times
X is being what? Cubed. Y is being, and this is a plus. Or make that word start with an S, it would be a sum. It's a sum of how many cubes? 2. Oh. Did we just learn how to factor sum of 2 cubes? Yes. So, from here out, you have to factor again. Okay? Over here, we have 2 cubes and a minus. Does this factor? Yes. So you have to factor it again. Alright, so you factor according to sum of cubes with this guy. Okay, I'm going to do that in green. You factor with difference of cubes. I'm going to do that in blue. Okay, so you're left with x plus y times x squared minus xy plus y squared. That's your sum. Now you do your difference. X plus y, or nope, sorry, x minus y, x squared plus xy plus y squared. Same thing as yesterday, whoops, except they're hidden within a problem. So from here out, anytime you see something that factors, you have to factor it. The directions are going to say factor completely. Alright? So this is where this gets tough because you have to recognize when something factors. Not just according to sum and difference of cubes or grouping, but according to anything you have done in your life involving factoring. Okay? It could all come into play here. Ron.
Shouldn't the first one be a positive and a green?
No. Opposite sign of what's ahead of it.
I thought the second one was
Yeah, this is the second.
no, like the second one.
No. This one's always plus. Okay? Always plus. Okay. Remember what I said earlier? We're going to have how many terms today, possibly? 6. Okay. 6 terms. All right? Okay. Oh, but you were listening, hopefully. Right? Yeah, of course you were. Of course.
I get caught up in
Caught up in the moment of the amazement of my teaching?
Yeah.
I do too sometimes, and then I lose track. Now, whenever you have 6 terms, there's a couple of different ways you could go about it. You could, honestly, you could rearrange to do it so you have 2 terms in 3 groups. I'm going to just keep it where I have 3 terms in 2 groups. Okay? Point being, I want my groups as big as possible. Okay? That way I only have to factor out twice and match up 2 things, not factor out 3 times. I have to factor out match up 3 things. Okay? So I factor my biggest groups I can. So if I see a problem with 6 terms in it, I group them in 3s. You can do it in 2s. I think it's a little tougher. All right? But someone was trying it yesterday and they did pretty good with it. So if you want to roll with that, that's fine. The nice part, this one's set up for you. Okay? So a cubed x squared minus 6a cubed x plus 9a cubed. The first group. What's your GCF out of the first group?
Cube and a cube.
A cubed. There you go. All right, there's an a cube in each. You're left with x squared minus 6x plus 9.
So you can only take one x out of the other one because it's on this.
Right.
This one's still
So you can't do the x's. That's why it's still there. Same old.
But I thought it'd just be x.
Yes or no?
Because you can't do an x out of these. You could do an x out of the first 2, but that's going to do you no good down the road. Okay. Jazz?
So like as far as like this negative b cubed, if you take that
you have to do like a negative b cubed,
Mm-hmm.
even though like it's plus 6b cubed x.
Mm-hmm. Because then this will turn this middle term to negative. Okay, see? Because you want the first term to be positive, the second one to be negative, the last one to be positive. So we take out that negative. All right, Lydia?
Wait, are you saying, why don't you just do b cubed and then do negative x squared?
You got to get this to match the next one. So see how x squared is positive here? If you just did b cubed, then you'd have the negative x squared. Okay, so they have to be the same. So if they're the same but signs are off, you take the negative out, which is going to leave you with the x squared minus 6x plus 9. Okay, now everybody see you had the trinomial as the same? Okay, so that's what's common. That's your grouping term, so you bring one of them out. All right, I'm going to write it a little different. I'm actually going to put what I have left over first this time. So a cubed minus b cubed. And then the trinomial is x squared minus 6x plus 9. Okay. I have a method. I have a reason. It doesn't. It doesn't matter. Okay. I'm anticipating what you guys are going to tell me next. Okay. That is not the answer. Okay. Because hopefully something very quickly sets off in your head of what else factors, which would be what? The a cubed minus b cubed, right? It's difference of cubes, okay? So then you have to factor that. All right? So a minus b, a squared plus ab plus b squared. Okay? That factors down here.
You want me to just bring the other thing down?
Well, does it factor?
No.
Yes.
How so? Oh, well, that's the question. If it does, how? Maybe I'm just messing with you right now. I asked the question. Maybe it doesn't factor.
3?
It doesn't have 3 x's, or it doesn't have...
No, the number 3, negative 6, 9.
But
Yeah,
you
one.
have
What?
a number in front of x squared.
It's 1.
Right, but how do you calculate
How you calculate 1?
1?
T-Stone.
Isn't it like x negative, or x minus 3 over x minus 3, right?
Good. X minus 3, x minus 3. Also known as a perfect square trinomial. See what I said? Everything we have done. You did this with completing the square, remember? Where you get one like this, you would factor it to a binomial being squared. You would take the square root. I know that was November. I know you're all like, I can't remember what I had for breakfast yesterday. But you did it. Okay? You have to know when you have to factor. And you have to know how to factor. Okay? And this is going in with the rest. Okay? With what we're going to do later. Alright? Tomorrow. Okay? So, x squared minus 6x plus 9 factors x minus 3, x minus 3. Okay?
So how?
You could also, real quick, you could also write that as x minus 3 quantity squared if you'd like. Okay? Okay, now, on the ones where you have to change your terms around, conceivably, there's a bunch of different ways you can do it, okay? Because think about this. We're each going to get 2 binomials, okay, as a final answer. So you can make your groups equal the first one or the second one. Okay, so however you see this, as long as you make it work, you're doing it correctly. The key is, do you understand how it works, and are you doing it correctly? Obviously. But here's what I look for. I don't really look at my numbers too much. I look at my variables. Okay? I look to my variables. And so I see this 6xy here, and I see a 5y over here, and no y's anywhere else. All right? So what I'm going to do, I'm going to flip the negative 5y with the negative 40 and group my y's together. Okay? So 6xy minus 5y plus 48x minus 40. That's fine.
Hey, Mr. Moore,
That's perfectly fine too. Okay? It doesn't matter no matter how you do it. Okay? Yes.
how do you get to the rate on the factor on your calculator?
I'll show you guys that in a little bit. Okay? The first group you have y's, so take a y out. Alright, which gives you 6x minus 5. Okay, and remember, as long as your second group is going to make a 6x minus 5, then you're in good shape. Alright, so take out an 8, which leaves you with 6x minus 5. Ron, please. Okay, so 6x minus 5, y plus 8. Alright, that's perfectly okay. Alright, you could group them together in like basically, I don't know, I'm pretty bad at my permutations, but I think it's like 16 different ways. Because you can group it so that you take a 6x out first, and you're left with the y minus 8. You could take a negative 5 out, you're left with the y plus 8. All right. You could rearrange it so that you take a 5 out first. There's a lot of different kinds of combinations you can do. Okay. That's why it's important to understand, to be careful, and work it slowly. All right. Now, that being said, on the last one, I see a pattern that I want you guys to kind of start recognizing. All right? I have n cubed, n squared, n, and no n's. Everybody see that? You got 6n cubed, 16n squared, 15mn, no n's. If you put it in that order, it's pretty in standard form order with one of your variables, even though you have more than just n's. Your chances are pretty good that you just factored it correctly, or at least you organize it so you can factor it correctly. Okay. So if you see one of your variables going down from 3 to 1 to none, that's a solid bet. That's a pretty good order to do. Okay. And after that, just try your GCFs. Okay. There could be a little trial and error with this. All right. Maybe you flip flop two terms, and you take a GCF out of the first group, and you can't make it work the second group. That can happen. Okay. There is a way that can happen. So you just kind of have to work these, practice, see where you're going. Okay. Sam.
6x minus 5 plus y plus 8. That's good.
Yes. Yeah. Okay. Clea?
So like only when we have like 6 terms on these, or we have to plug.
Not necessarily. I could set the ones with 4 terms up to have something that factors down here too.
Don't do it.
I could.
Don't do it.
Okay. Ease?
Is it? Never mind. Keep on.
Okay. So you take out a 2n squared, which leaves you with what? 3n plus 8m? Whoops. Take out a plus 5m, which leaves you with 3n plus 8m as well. The 3m plus 8m's. Whoops, flipped them. Oh! All right, page 346. 1 through 10.